This is the Econometrics final review for Econ 382. For the first question, when are ordinary least squares models okay to use when the dependent variable is a dummy variable? They're okay to use when the number of observations is reasonably large. Otherwise, you would want to run logit or probit models, which are the preferred models when the dependent variable is a dummy variable or a binary variable, and then calculate the marginal effects. For the second question, we have a model where the dependent variable is a dummy variable. So we are predicting the probability of being married. And the independent variables we have a dummy variable or a binary variable for whether or not the individual lives in the South, and then two continuous variables for highest grade achieved and the number of hours of work. So we have the following model. Again, the dependent variable is a dummy variable, so we will have to interpret the coefficients accordingly. And for the coefficient on South, we want to note that the predicted probability of being married, right, so the coefficient here is 0.0110. So we interpret this as predicted probability of being married is 1.10 percentage points higher for those living in the South than those not living in the South, holding all else constant, or holding grade and hours of work constant. So keep in mind you want to multiply this by 100 since the outcome is a dummy variable, a value between 0 and 1, or a value rather of 0 or 1, and so the predicted probability is going to be a value between 0 and 1. So we multiply this by 100 in order to get a percentage point change. So keep in mind it's a percentage point change, right, and not a percentage change. We only use percentage changes when we have natural logs. Okay. For the second coefficient, the coefficient on grade, that's a value of 0.00049968. So we multiply that by 100, and the predicted probability of being married goes up by 0.4997, or 0.5 percentage points, as grade goes up by 1 year or 1 unit, holding constant South and hours, or holding all else constant. So for the coefficient on hours, we have a value of negative 0.006687. So we multiply that by 100, and as hours of work go up by 1 hour or 1 unit, the predicted probability of being married goes down, right, by 0.6681 percentage points, holding all else constant. So for part D, it asks you, since the number of observations is large, OLS would provide us with a good or bad approximation of the marginal effects? Well, the number of observations is extremely large, 2,240 in this case, and so we would be provided with a good approximation of the marginal effects if we simply used an OLS model.